In this problem, we have to solve an initial value problem given by a differential equation and a condition x at 1 equals 0, which is equivalent to 1, 0. So first of all, we need to find the solution by using a method we know. This equation is not separable, but it might be linear. So what to do to check if the equation is linear or not? We isolate dy dx, dx dt in this case, dx dt, by dividing each of the single terms by t squared. So we have five over t x equals to t squared ln of t plus 1 over t squared. So as you can see, this equation is written in linear form. This expression multiplying x is p of x, and the term on the right by itself is q of x, so it is linear. But in this case, since the independent variable is t, should be p of t and q of t. Then we are now going to proceed to find the integrating factor u of t, which is e to the integral of p of t dt, and that is the integral of e to the integral of 5 over t dt, and the integral of 5 over t is 5 ln of t, which is equivalent to e2 ln of t to the fifth, and finally t to the fifth, provided t is a positive number. You remember, the argument, the domain of the log should be a positive number. So t is greater than 0. So now we're going to multiply the whole equation, the given equation, this is our equation, and we multiply by the integrating factor, which is t to the fifth. Once we do that, we have t to the fifth dx dt plus 5t to the 4 times x equals 2 t to the 7 ln of t plus t to the third. And notice that the left side of this new equation, it is the derivative of a product, and that product is formed by our integrating factor, which is t to the fifth times x times the dependent variable equals the right. Then to solve the differential equation, we need to apply integral on both sides. So on the left, the integral cancel the derivative. We have t to the fifth times x. And how are we going to find the integral of the right? Well, we have the term t to the 7 times ln of t. So this integral can be found using integration by part, the integral of t to the 7 ln of t dt. So u is ln of t, du is 1 over t, and say dv is t to the 7 dt, and then v is t to the 8 over 8. So that is a strategy to solve the integral for t to the 7 times ln of t. So now this integral is equivalent to v, which is t to the 8 divided by 8 times ln of t minus the integral of v times du. That is t to the 8 divided by 8 dt times v. So it will be t to the 8 divided by 8 times 1 over t dt. So this is equivalent to t to the 8 over 8 times ln of t minus the integral of t to the 7 divided by 8. So that would be what? T to the 8 divided by 64. Right? Okay. So our equation would be the left, t to the 5 times x equals to the right. Well, the right, we found the integral of the first term is t to the 8 divided by 8 ln of t minus t to the 8 divided by 64 plus the integral of t to the third, which is t to the 4 divided by 4 plus a constant c. And then finally isolating x. Remember, x in this case is the dependent variable and t is the independent variable. X of t will be, we divide everything by t to the 5th. So we have t to the 3rd divided by 8 ln of t minus t to the 3rd divided by 64 plus t, or simply 1, right? T to the 4th divided by t to the 5th would be a t on the bottom, 4t plus c divided by t to the 5th. And then this is the general solution. So our solution, to find the solution of the initial value problem, we have to plug the condition, which is x at 1 equals to 0, which is the same as replacing in this equation that we found the point 1, 0, and then you will get the solution, and simply, you will get the value of c, and then once you get c, plug it in the equation.